Hello. Said I'd post a video since we didn't have class today, so here I am posting a video. I know that this was your homework last night, these 4 on top. I'll do number 5, then I'll do number 7, number 8. You guys are gonna finish this packet for homework, including these back examples. Alright, very exciting. I know some of you are feeling like Leia, but hopefully this video is gonna help that out. Alright, so I've got my, and this is the pen I was using last time. It is a Uni Jetstream, for those of you wondering. But I have a Swell pencil since I'm gonna be doing a graph, and I know I'm gonna mess up. Alright, I also have a bunch of blank paper to show all of my work, which is what you should be doing. Alright, so we've got this function f of x equals x to the third plus 3x squared minus 18x minus 40. Alright, so I'm looking at this and I'm going to figure out what the end behavior is and then what the zeros are and then try and fill in some blanks there. Sort of think of this as like a puzzle, and the zeros and end behavior will give me a few pieces and I sort of have to build the other pieces. Okay, so first thing, end behavior has a degree of 3, which is odd, and has a leading coefficient of 1, which is a positive number. That means that as x gets really big, f of x is also going to get really big, and as x gets really small, f of x is also going to get really small. My beautiful infinity symbol, look at its beauty. Okay, so when I draw my graph, it's going to be going up like that and down like that somewhere. All right, but I don't know where that's going to happen, so let me erase that. I should have done that. Okay, so now let's figure out the zeros. So I'm looking at this and I'm saying, okay, can I factor it? No, I don't think so. This would be x, it would be x plus 3. Yeah, cannot be factored. All right, so let's use rational root theorem and Descartes' rule of signs. So first of all, Descartes' rule of signs, I see one sign change. So that means I have one positive root. So I'm making my beautiful table here. If I plugged in negative x, this would be negative, positive, positive, negative. So I could have 2 or 0 negative roots. If I have 2, that's going to be 0 imaginary, and if I have 0 negative real roots, that means it's going to be 2 imaginary. So let's use rational root theorem to try and figure this out. So rational root theorem, I've got 1 as my leading coefficient and negative 40, or just 40 as my constant. So let's look at factors of 40. Factors of 1 are pretty easy. So I got 40, I got 20, I've got 10, 8, 5, 4, 2, and 1. I think that's it. All right, and I've got my plus or minus because it could be positive or negative, and then just 1. So all of my possible zeros could be any combination of this factors of 40 over 1. All right, so I'm gonna test some easy ones. I don't know, I'm gonna do positives. So let's start with 1, f of 1. So if I do f of 1, then I'll have 1 cubed is 1, plus 3 times 1, minus 18 times 1, minus 40. So 1 plus 3 is 4, negative 4. So this is not going to be 0. All right, I'm not even going to do the extra work. Okay, if I use f of 2, Leia's turning her back to me now. I think she's getting sick of this math. Hopefully you're following along just fine. Okay, f of 2 will be 8 minus 12, plus 12 minus 36 minus 40. Okay, Okay, still not going to be 0. Let's go on to 4. I got 64 plus 48 minus 72 minus 40. Okay. I think it's gonna equal 0. So I've got 4 as a factor. So if you don't like using remainder theorem, you can just go ahead and divide. I think it takes a little bit longer, but if you don't think so, that's fine. All right, 1, 3, negative 18, negative 40. So let's use synthetic division. So bring down my 1. 1 times 4 is 4. This is going to be 7, 28, 10, and 40, so good, 0. Okay, so now I have this polynomial, which is my constant, linear, quadratic. This is a quadratic. Okay, if you have a question on how to do synthetic division, please see the other video or send me a message. All right, so by the way, so far we have x equal to 4 as one of our zeros. So now this is a quadratic, so I could either factor it, I could use completing the square, I could use Descartes' rule again, I could use quadratic formula, and yeah, that's pretty much it. I cannot use inverse operations because b is 7. To use inverse operations, b needs to be 0. So I'm looking at this, I see 10 and 7. In my head, I'm thinking, okay, 5 times 2 multiplies to positive 10 and adds up to positive 7. So I'm going to use my trick and just do x plus 5, x plus 2. So be careful, this is not my answer. These are my factors. So every time you see something that says factor, this would be the type of answer you'd be looking for. Since it says 0 and I'm trying to find the zeros, that's when I take this factor and I set it equal to 0, which would give me negative 5. And for this one, negative 2. So now I have 3 zeros. Okay, here they are. How many did I need? I needed 3. So if we go back to Descartes' rule of signs, it was this case. I have no imaginary roots, so I have 3 zeros that I can plot. Okay, so far I have 3 points that I can plot on the graph. 4, 0, negative 5, 0, and negative 2, 0. All right, so I know my end behavior. I know my points on the graph, 3 points on the graph, and now I just need to sort of fill in the blanks. So one thing that I could do to fill in the blank is figure out what the y-intercept is. So f of 0, if I substitute in 0 up here, I'll have 0 plus 0 again, minus another 0, minus 40. So I'll have this point 0, negative 40. So on my graph, I'm gonna plot all this stuff. Negative 40 is gonna be like way down, so I'm just going to kind of go off the graph a little bit, and this is just a sketch, so that's okay. All right, so I have 4, 0, 1, 2, 3, 4. I have negative 2, 0, and negative 5, 0. So there are my zeros. Between these 2 zeros, I know that it's got that y-intercept like some way down there. So I'm gonna draw a little arc like this, a little parabola looking thing. Okay. Next, I'm going to try to find a point between these 2 zeros. By the way, I know that this is going to go up something like that. And if I wanted to figure out the exact value that this would be, it's going to be somewhere really high. I'm not sure where. It's going to be something pretty high. So I'm just going to draw this. This is fine. We're just sketching. Okay. All right. This graph is looking better by the second. All right. So I'm going to just pick negative 3 because I think that negative 3 is the easiest. So we'll do f of negative 3. So I have negative 3 cubed plus 3 times negative 3 squared minus 18 times negative 3 and then minus 40. All right, so this would be negative 27 plus 27 plus, I think this ends up being 54, and then minus 40, which when you add all these things together, you should get 14, I believe. All right, so that's gonna be off the graph too. That's gonna be somewhere like up here. So I'll draw my graph like this, and then it's not like that. It's kind of tough to do this with one hand because I'm not able to hold my paper. All right, so our end result should look something like this. All right, by the way, to do number 6, remember SOAP. Think about your cubes. Difference in sum of cubes. Okay, you know what? I'm gonna just do this one, and then hopefully that'll help you with this. If I need to make another video, please let me know. All right, this one should be pretty quick. I'm looking at this, x to the 4th plus 1. This is not the difference or sum of 2 cubes. All right, so I cannot factor this. If I'm looking at this, I don't really have any. If I use 1 is my constant, and 1 is my leading coefficient. So Descartes' rule of sign says that I'm gonna have, by the way, oh yeah, let's look at Descartes' rule of sign. Almost forgot. So right now there are 0 sign changes. That means there is 0 positive. So if I plug in negative x to this, there are still 0 sign changes. So I'm looking here, whoops. I'm looking here. I'm noticing that I'm gonna have 0 real solutions. So think for a minute about what that means in terms of the graph. Obviously it means there's gonna be 4 imaginary solutions. So remember when we're talking about a graph of a function, we're talking about when we're talking about roots or zeros of a graph, we're talking about x-intercepts, so where it crosses the x-axis. So if they're all imaginary, since we are using the Cartesian coordinate plane, that's what this thing is called, since we're using this, which is only consisting of real numbers, that means that this graph, the graph of this polynomial, is never going to touch that. So we need to really just basically make a table. Need to make a table and know what our end behavior is. So my degree is 4, and my leading coefficient is 1, so I know it's going to be going something like this, like sort of like a parabola that opens upwards. And yep, that's basically what this is going to look like, a parabola. So let's make a table. I've already done a lot of this work, so I'm not going to do it again, but I'll show you the table. So here's my table. So I'm going to go from -2 to 2. And that should be enough information for us to draw our curve. Our parabola looking thing. There's not really like a hard, fast rule about how many points you need, but if you can get 5, I think the more points, the better. The more points you make, the more clear it's gonna look. So if you plug in -2 to this, you should get 17. -1, you should get 2. 0, you should get 1, and then it's sort of like a parabola, so it's reflecting like this. Okay, so we're just gonna plot these points. 0, 1, 1, 2. Okay, and it looks just like a parabola at this point. These points are way up here. Okay, and again, really difficult to sketch a graph with one hand. All right. If you guys are stuck and you want me to post another video for number 8, please let me know and I'll do it. Otherwise, you can just ask me questions on your mind. And don't forget, this whole packet is due for homework, okay? Enjoy your snow day, stay safe, love you, have a great day, bye.